Do you want me to revise what you just what you studied yesterday or on the last class? A quick repeat. Shall we go through that? Yes. Cool. Now, what we will do? Okay, there are some students who haven't attended the yesterday class, and they're saying, "Have a quick repeat." Will it make any sense, guys? Will it make any sense? No, not at all. But there is something called give it a shot for your wish. Because first of all, when instructor is being changed, it's very like it's not easy to go through the transaction. And if you are listening to the middle of the topic, it becomes too tough, as for me. Cool. We had the session on 9th. Am I correct? We have the session on 9th or 8th? 8th, right? Cool. So I think this is the board. 8th. Yeah, I got it. So what we decided that we want to store the values. What we want to store? We want to store the Indian phone numbers. Am I correct? So what's the typical number of digits available in the Indian phone number? 10 digits, right? So for that, we tried various options. One of the option was using an unsorted array. We figured it out that when I was using the unsorted array, insertion is big of 1 because I'm storing the element at the end. Inserting is big of 1 because I'm inserting the things at the end of an array. Searching was big of n because data is unsorted. So if data is unsorted, I have to perform the linear search. If I'm doing the linear search, complexity is big of n. A rational argument. Make sense? Guys, yes, no? And even if I want to delete, first of all, I will search and then delete. So searching is taking big of n and then I will shift the elements. So overall deletion is also big of n. Let's say that. And we made the rational argument that even in the worst case, you're deleting something, the exact number of iteration won't be more than n. Why so? Let's take that. Data is 1, -1, 10, 7, 8, and let's take 100. The point is, if you want to delete 100, how many iteration will it take to find 100? Sorry, if you want to delete 10, how many iteration will it take to find 10? Guys, how many iteration would be required to find 10? Exact number of iterations. Exact number of iteration if you want to find 10. It's 3. Everyone, it's 3. Guys. If I'll perform linear search, I can find 10 within 3 iterations. Yes, no? Few students who are early responding are not at all replying on the chat box. I think you know your name. 3 for finding, and then you will make the shift. So you're shifting 2. So there were 5 elements and 3 plus 2 is 5. So can I say that deletion is also happening in big of n? Similarly, we had tried with the sorted array. The complexities were n log n and deletion was happening in big of n. Again, linked list entries, I said that when you will be learning these topics, you can fill up the table. Then there was a concept which was called DAT, direct access table. So what I was doing in the direct access table, can anybody who wants to explain it to me? A quick revision. And I'll also get the clarity how much you're able to understand the stuff, what I'm discussing with you. Is there anyone who wants to explain what is DAT? Direct access table. You can raise hand. Have confidence, guys. If this thing is asked in the interview, you can't sit silent. Anyone, give it a shot.
Hello?
Go ahead, Aman.
Yeah. Am I audible?
Yes, you're audible, Aman.
Yeah. So, basically, it stores data in key value form.
DAT.
Yes.
Okay, go ahead.
It stores data in key value form.
Hmm. So how I will perform the insertion in
And
DAT?
sir, we will simply suppose there is a list and which consists 5 elements,
Mhm.
and if we want to add any element at particular index,
Hmm.
suppose L of AR of 0 is equal to 10, and if we perform another operation AR of 0 is equal to 5, then it will store at the same index.
Hmm.
Yeah, in key value pair.
Mhm.
Yeah. And it is possible only for the when the key is only integer.
Got it. But is it in DAT what you're trying to explain? You're trying to explain me the concept of mapping. What was DAT? Let's suppose you want to insert a data 10. Okay, go ahead. Bhuvnesh, go ahead.
So DAT is a process
Mhm.
of mapping a record to the corresponding keys while using arrays.
Correct. So if I want to store 10, what should I do?
So the fact means mod of that corresponding size, put the value over there directly.
Okay. So DAT was, if I want to store 10, I'll write array of 10 and make it true.
Yeah,
If I want to delete 10, what I will do?
make it false,
Make it false. And if I want to search anything, what I'll do?
equal to true again.
Yeah, I'll check whether it's equal to true or not. So what was the
Yes,
problem with the DAT? Every number was paired with the index directly. Am I correct?
yeah,
So what was the problem which you were facing? In the worst case, there are 10 digits number. So it's 10 to the power 10. And if I need 10 to the power 10 as an index, it will occupy 10 gigabytes of the memory.
yeah.
Is it clear to everyone? Guys, you can respond to the chat box. Is it clear? Remember that concept and you've seen this conversion. So DAT is an awesome thing because just making things as true, just making things as false, and just checking whether it's equal to true or false will be done in the constant time, which is nothing but big O fun. So everything is happening big O fun, but it's occupying so much of space. That was the problem. Am I correct? How did we solve that problem? We say that I will have the fixed size array. I will have the fixed size array. And what's the fixed size of an array? It was 10. In our example, it was 10, right? Then what we did? We did 100 mod 10, we got 0. We did 98 mod 10, we got 8. We did 99 mod 10, we got 9. And 45 mod 10, we got 5. So what conclusion we made? Whatever the value is, if I'm doing mod with 10, the result would be between 0 to size minus 1, which is nothing but 9. Is it clear so far? Vishnu, is it clear to you? Cool. Yes, let's go ahead. Now the point is, we try to store 3. If when I find 3 mod 10, what's the result? I got 3 mod 10. The value was 3. That means I've stored 3 in the third index. Then I tried to store 17, where I should store 17 in the seventh index. Then I tried to store 48, where I should store 48. Guys, where I should store 48 in the eighth index. If I want to store 6, where I should store 6 in the sixth index. Now I want to store 97, where I should store 97 in the seventh index, but seventh index is already filled. See, 97 mod 10 will give you 7. 7 index is already filled. If index is already filled, we run into an things. You can say that two different hash keys are fighting on the same index. Collision happens in the real life. Ek anar, saw bimar. Index is 1, and there are many keys who want to get into that index. So what solution we did? At each index, we stored an array list. At each index, we stored an array list of list. Correct? Now, at each bucket, array list is present, and that array list can store multiple values. See, at one index, you can store one value. So in that index, a reference of an array is being stored, and that array list is storing multiple values. Seems possible, seems true. Guys, clear so far? It's clear to Gaurav, Krishna, sorry, Kishan, Vishnu, others. Is it clear to you, Aman?
Yes, sir.
Bhuvnesh, is
Sir,
it clear? Yeah,
sir,
go
I
ahead.
have a doubt.
Mhm.
Sir, if we are storing 10 elements at seventh index, then how we will write?
You're storing 10 elements in the seventh index.
Yeah.
No, that's what we discussed, right? If the values are 17, 87, 97, 107, everyone wants to go into the seventh index, right? If you
Yes.
do the mod, you will get 7. Am I correct?
Yes.
So once you did 117 mod 7, what you got? 7.
Mm.
That means I have to store the things in this bucket. Make sense?
Yes.
So what's the array list stored over here? First of all, I should retrieve it.
Yes.
Can I call al dot get of 7? When I
Yeah.
will write this code, I'll get the list which is stored in the seventh index.
Yes.
Now, can you tell me in an array list, if I want to add 17, what should I do? List dot. Do you know array list or not? Aman, do you know
Yeah,
array list?
I know.
So how you add the elements into the list?
List dot append.
Append, or you can call add, right? If I'll call list dot add of 17, can I say that 17 will be added to the array list?
Yes.
So there are 10 array lists available. In which array list things has been added? The array list which is present in the seventh index.
Yes.
Correct? Clear so far? Let's say 87 comes up. If you do 87 mod 10, what you will get?
7.
7. So that means he says then I also want to go to the seventh index.
Yes.
So what's the solution he has bring? I'll call al dot get of 7. Can I say that I'll get the same array list which is already storing 17?
Yes.
I'll got that list. On that list, what should I do? I should call list dot add of 87.
37.
So can I say that in that same array list, 87 is also been appended,
Yes.
right? And guys, we have seen that if I'm performing the insert operation without even checking whether that particular value is present in that array list or not, what's the drawback? The drawback is unnecessarily chain length has been increased.
Mm.
So if it's an unsorted array, we figure it out that insertion was happening in big O of 1, searching was happening in big O of L. Let's say L is the length of the chain, and deletion was also happening in big O of L, right? That means number of elements present into that array list. Now the point is, if I want to make insertion work in the big O of 1, I don't have to check whether that element is present or not. I'll simply go to the end and append the new number. But the point is, if 17 is repeated 10 times, I'll add 17 10 times into the list. And if I'm adding 17 10 times into the list, I'm unnecessarily increasing the length of the chain. If the length of the chain is unnecessarily increased, search and delete operation will be affected. Because if length is increased, L is increased. If L is increased, it take more time for me to search. So that's the reason why hash map and hash set does not allow duplicates. A valid reason, right? So in an interview, if he's giving you, if you're writing the code, if you're solving any particular problem statement, you have used the hash map. Once you write anything in the code, he has the full right to ask questions. If he's interested, he will directly straightforward put up the questions. How does hash map work? And you know what I used to do, like it's in game. So for example, you have given me the problem statement to solve. So what I'll do, I'll write the code, and let's say I've used hash map in that or hash set in that. So you'll say explain me the code. When I'm explaining in the code, I'll say that see, I can also use array list to store the value. I can use linked list to store the value, and I can also use hash map or hash set to store the values. Am I correct? Guys, I can use all these three to store the value. Then I'll say that yeah, I have used hash map because insert, search and delete is happening in big of one, and I don't want to waste my time in searching the things, right? If I will use array list, it will happen in the big of n. That's why I have used hash map or hash set. Now, as soon as I have said that, interviewer will think he's smart. If he's smart, what he will say? He will say, and if you're going good with the flow, he'll say, why you say that hash set and hash map works in big of one? That means he wants now you to explain the concept of hashing. So the point is, he has started the game by giving the problem statement. Now it's in your control. And I know the internals of hashing. I'll explain it. If I'll keep on explaining, I can easily able to engage him for the 15 minutes, right? And one more thing can be, I want to filter out the duplicates, so I have used hashing in it, hash set in it. So again, I will say why hash set does not allow duplicate. So you can say that there is a bucket system, and you can explain all the logics. If it allows duplicate unnecessarily, the concept, the complexity of search and delete is gonna affect it. But the same time, insertion will happen in big O fun. But the overall performance of the data structure has been reduced. That's why it does not allow direct insertion. It used to first check and then insert. The point is now you are driving the interview. And I say that nobody can answer all the questions. But let's say you solve the problem statement, you 10 to 15 minutes would be normal conversation. And if you explain them this concept, I think it will work. Right? Why I'm emphasis is on that? Because I have seen interviewer asking these questions. Right? I just don't want to name the companies, but yeah, they used to ask. Now, what's the next thing which we have faced? What's the next thing we have faced? Okay, I'm creating the bucket. I'm want to distribute the things, but let's say element comes into the sequence like 17, 27, 37, 87, 97, 107, 127, 117. Everything will go to which index? Seventh index. So instead of being big of one, it has become big of n. Big of one, we want to achieve big of one, but it has become big of n, right? So we should have a good hash function. What's the characteristics of good hash function? First of all, it should uniformly distribute the key. Second, it should easy to compute. See, exact uniform is not possible. For example, okay, leave that part. And it should be easy to compute because I want to achieve something in big of one, and I should not waste my time just to compute where I have to search, right? So it should be easy to compute. So we come up with two hash functions. What are the two hash function? I'll take the last digit. Second, I'll take sum of the digits, right? And I've combined two hash functions together. Why I have combined two hash functions together? The reason was to randomize distribution, or I want to uniformly distribute the key over the hash function. Now, see, in the previous hash function, I was very easily able to come up with the solution where all the keys will go to the same index. But if I've combined two hash function, coming up with an example where all the keys will go to the same hash function is very hard. It's not as easy as in the first case. Yes or no? Guys, do you agree with me? So whatever you have studied so far, shall we implement? Why two hash? See, one, okay. Vishnu, what the point is, if you're using the first hash, everything is giving 7. So everything will go to the 7th index. But let's say in the second example, the hash, there are two hash function, h1 and h2. What h1 says that sum of digit. When you add 87, what's the sum of digit? 15. 15 mod 10 will give you 5. This is your first hash function. And if you take the last digit is 7. 7 plus 5 is 12. Then 12 mod 10 will give you 2. So basically 87 will go to the second index. Correct? Same thing when you will do it with the 97. First hash function, 9 plus 7 is 16. 16 mod 10 will give you 6. And the last digit is 7. 6 plus 7 is nothing but 13. 13 mod 10 will give you 3. That means 97 will go to the third index. Vishnu, is it clear? Is it clear? Vishnu didn't get the point. You can unmute yourself. Go ahead.
It's like getting too complicated. What if there are like thousands or millions of number? It will become super complicated.
What bad becomes super complicated?
No, so 87, 97, 197, 297, so many things. There will be again collision in spite of.
I'm saying there will be collision. Did I say that there won't be any collision? But the point is, 87 and 97 were earlier going to the same bucket, yes or no?
Yeah,
Now they're going to the same bucket or two different buckets.
yeah, two different buckets.
So that's the point of randomizing the stuff, right?
Okay.
I'm not saying there won't be any collision, but at least there would be an evenly distribution. It's very hard to predict which number will go to which bucket.
Yeah, okay.
Correct. So you're just doing the uniform distribution.
Right.
Now again, let's say you have 10 buckets and there are 50 numbers you want to store. 10 buckets, you want to store 50 numbers. Correct?
Yeah,
Each bucket will get at least around 5 to 7.
yeah,
5 to 7.
yeah. If it is balanced.
Yeah. Yeah. It's if you use a good hash function, it won't be more than 7.
Okay.
Okay. Now the point is if I double the size 20, then it will be around 2 to 3.
Yeah,
It will be approximately equal to big O of 1.
yeah,
Yeah, that's the point. We have to grow closer to the big O of 1. We can't go exactly big O of 1, but if it's big, approximately equal to big O of 1 is far better than having big O of n, right?
yeah.
So whatever I've studied so far, shall we implement this? So there are a few students who haven't attended the yesterday class. Are you able to get it? Not personalized to anyone, but if you're able to get it, then it's great. Like you're having a nice thinking capability if you're able to get it. Yeah, yesterday means Friday.
One more question, sir, is
Go ahead.
in Java, the hash key function
Hmm.
gives them like strange numbers. Mm,
This is that is nothing but your hash code, right?
yeah, hash code. Yeah. So
Okay.
what algorithm does it use? You're talking about SHA or something like that?
No, SHA is nothing but it's an encryption algorithm.
Okay.
So we are not going with the encryption as of now, right? So if you're talking about the hash code, I'll took the support of Eclipse to generate one hash code, and let's see what it returns.
Okay. Go ahead.
Yeah. Hey guys, do you remember on Saturday teachers used to say, "Let's meet tomorrow." Tomorrow means Monday, not Sunday, right? And we used to say, "Will you come here to clean the classrooms?" Yeah, these are the lame jokes as of now, but yeah, we laughed a lot at these jokes, as per me. Correct. Does anyone has any idea why Kapil Sharma is so much famous in India and how he got so popular and so quickly? Yeah, there are lots of people who are doing comedy in India, but Kapil Sharma got the, like, you can't match the popularity of Kapil Sharma, and it becomes so quick. When he was participating in some of the, like when it was his first reality show, they were not ready to take him, and he ended up winning it. Anyone? Yes, he can take joke on himself, and whatever his jokes are, it's related to the common person's life. Right? Okay. Guys, these are the function. If you want me to explain, or shall I code it in front of you? Whatever you say, whatever is preferable. Do you want me to explain, or shall I code it in front of you and remove this entire stuff? Okay. So I'll explain it. ID is not, you're not able to view the ID. Okay. So what we will do, we will code it. We will code it together. Just give me a minute.
So I think explain it, and if next day we are not able to do, we can code it so that we can use our. I mean, I can use my brain a little bit. Yeah, I was saying that explain it and then we'll code it and bring it tomorrow.
Guys, will it work for you? Like what I will do, I'll explain you the insert and the search and the delete. I'll leave it for you to implement. Cool. Okay. So what we decided, where we want to store the stuff in an array list of integer. Yes or no? Guys, shall I create it? Array list of integer. So let's call it as list. Okay, cool. I have to share it. Guys, is it visible to you? ID. Right? So what I did, I just created an array list of integer. Is it clear so far? Now, the point is the size of this array list, I don't want to fix, but I want that whatever the size I'm passing in the constructor of the custom hash map, that should be the size of an array list. So can we have a constructor for it? Public int size, right? Now, can I write in this manner list of and I can pass size to it. See, internally, it will create an array list. It will create an array list of size 10 internally. But am I allowed to access 8th and 9th index? Am I allowed to access? Guys, in the size function, okay, a basic question. In the size function, if I'll pass 10, am I allowed to access list dot get of 9? Yes or no? Am I allowed? Everyone? Yes? Okay, cool. Just give me a minute. And let's have a zero param constructor as well. Public custom hash map. Okay, cool. Just a constructor, I've declared it. Now, let's say that I'll write this piece of code somewhere here and I'll pass the size as 10. And let me write, okay, just for an understanding about this concept, I'm making list a static and let me write down sys like control Z. I'll simply write list dot get of 5. Let's see. Let's run the code. So ideally code should compile, right? Index outer bond exception, length is 0. The point is internally it has created an array of size, and you know that array list is growable. So initially it will have the size 1, then it will have the size 2, then it will have the size 3. It will double itself or 1.5 times of the current capacity. Yes, do you know this stuff or not? Guys, yes, no. 1.5, right? So it's 3, then it will become 4.5. Let's take 5, then it will become 10, right? The point is, I don't want this multiplication to begin. I want that initially you should give me the list of size 10. So it is internally created an array of size 10, but you're not allowed to access any one of the index. Is it clear? Yes, that's why when you return this code, you got an exception. So what should I do? I should run a for loop int I equal to 0, I less than 10, and I plus plus. What we decided we will store what in this array list? Yeah, not less than 10. It should be actually less than size. So what we gonna store inside this list? List of integer. So can I say that list dot add equal to new array list, and empty array list we're gonna store? How many times? We're gonna store it for the 10 times. Let's say size is 10. Is it clear? Everyone, is it clear so far? So as of now, what had happened? Just you have created 10 buckets. Each bucket is storing an empty array list, right? Now, do you remember before performing the insert operation, search operator, and delete operation, you have to compute the hash function, right? So let's have the public. Actually, it should be private. It should be private because we don't want them to access outside the class, right? Are you allowed to use? No. Correct, you're not allowed to use. And even you cannot access the under beneath array list. So it should also be private as for me. Okay. So it doesn't matter if even if you're while coding, you're not declaring it private or what. If interviewer is asking, you can extend him your rational argument. Okay. So let's take public and the values int. Yeah, if you want, you can take long. As of now, we are dealing with the integers, it will work, right? So public int hash value function. And while computing the hash value, you will pass some value. So let's call it as X. And what we decided, it won't be the combination of one hash function, it will be the combination of two hash function. Yes. So int key would be the combination of two hash function. Let's name them h1 and h2. Just the naming convention. If you want, whatever name you want to give, you can give h1 and h2. I'll pass that, and then after that, what I'll do mod with size, because at the end, whatever the result is, I want within the range of the size, right? That's why I'm doing mod with size. Size is not available globally, so what you can do, int size, initialize it to 0, and in the constructor, what you can do, you can write this dot size equal to size. Am I correct, guys? Clear? Like, I should not teach you core Java. Okay, so let's create two methods, h1 and h2. So can anybody help me to write the code to find the sum of all the digits? Yeah, sum of all the integers. How should I do? If it's 123, I need result to be 6. Can you tell me the code? You have studied it when you're learning the fundamentals. Yes, no? Okay, write the while loop. While. What's the breaking condition? If you want, you can raise hand. It's fine. Or you can write in the chat box. Both will work for me. Kishan, just raise hand. Let's have a discussion. Great. Let's go ahead.
Yeah, we can.
Hmm.
Am I audible?
Yes, you're audible, Kishan.
Yeah, so we can take a variable. Yes.
Variable.
Maybe.
Let's take some.
Yeah, some.
Initialize it to.
Yep.
Okay, cool.
And
Hmm.
we can take one more variable, right? Let's make x greater than 0 as of now.
Okay, x greater than 0. Cool.
Inside that, we can have sum is equal to some percentile 10. We'll keep that value in sum.
Okay, you will do x mod 10, right?
Yep, x mod 10.
Right. Sum equal to sum plus x mod 10. Correct.
Yeah.
Then
From here we'll get the values and sum. So for example, 1, 2, 3, first 3, 2, 1. Yep. And we can return sum, right? It would work, I guess.
are you modifying x? Your x should also be reduced, right?
Yes.
You're every time extracting the last
X
digit.
divided by 10.
Be.
Yep. Now it's fine.
So I think I should return sum.
Now,
Vishnu, can you help me to complete? If I want to return the last digit, what should I do? Thanks, Kishan. Your code was correct. Vishnu, what should I do if I want to return the last digit?
Just the remainder of for that.
So how should I return the remainder?
Like percentage 10. And
what percentage 10?
Yeah, so x percentage 10.
Cool. That's it.
Yeah.
So here I should return. See, h1 will return something, h2 will return something, and then I'm doing mod with size. Don't you have any question? You're already doing mod with 10. Here again, whatever the result is. Oh, here mod 10, we forgot it, right? Here it should be mod 10. Am I correct?
Yeah.
Guys, yes, no. Mod 10. We made the sum, then we extract, but then we did with the mod 10, or you can say that mod with size.
Yeah.
Okay, how many of you are able to get it? It's clear to Vishnu, it's clear to Kishan. What about Bhuvnesh? Gaurav? Line 23. Okay. You're not able to understand line 23? Not clear why size. Okay. See, why I was doing mod with 10? Because we have taken, there should be 10 brackets, 10 buckets, right? But the number of buckets will depends on what's the size you're passing into the constructor. So that's why it's mod with size. It's clear to Kishan. Gaurav, is it clear now? For sure. Shall we move forward? Because I don't know what's the pace you grasp the content. That's why I'm asking repeatedly. Now you might be asking the question, already it's mod with size. Here again it's mod with 10. Why am again doing mod with size? Can be the question?
Yeah.
Yes. So the point is, let's take value is 18. If you will do 18, sum of the digits, it's 9.
Yeah.
9 mod 10 will give you 9.
Yeah.
If you extract the last digit, what it will give you?
8.
8. 9 plus 8 is 17. Can I say that it's exceeding the size of my list of my buckets? It's
Yeah.
exceeding, right? That's
Yeah.
why I'm doing again mod with the size so that this should come into the range. Cool. So once it is done, I should return key. Clear to all? This is done. Now let's try to implement our 3 magical functions, which is nothing but search. Return type should be Boolean. And let's see how you can perform searching. So let's take, I want to search for any particular value, whether that value is present or not. So first of all, what should I do with this value? No. First of all, I should know this value belongs to which bucket. Am I correct or not? See, yes, 87 belongs to the 7th bucket, 97 belongs to the 7th bucket. Similarly, I should know to which bucket does this value belongs to. Guys, is it clear? It's clear to Kishan. What about others? Is it clear? Clear to Gaurav too. What about others? Is it clear? Vishnu, is it clear to you? Bhuvnesh, is it clear to you? Yes. Guys, I should not ask, you should respond. So in order to get at which bucket I have to search, I should call a hash function, right? This hash value, and I should pass this value over here. It will return me the bucket where I should search, right? Then what should I do? With respect to that bucket, I should retrieve the array list, right? So I should write al dot get of key, al dot get of key. Am I correct? Why it's not allowing me to take al? Al is being declared. Oh, sorry, I have declared with the name list. So let's call it as al and let's call it as list. Okay, let's call it as list. Now the point is, now you have to search in that particular array. How can you search? You can simply call contains method and pass the value, right? So whatever this result, if it returns true, that means it is present. If it is returning false, that means it is not present. Am I correct or not? See, why to write if and else? Directly return. What's the return type of contains method? Return true if the list contains a specified element. Else it will return false. My work is done, right? See, if they will ask, you're not allowed to use the contains method. Okay, I know how to iterate on the list, right? See, even your contains method is also doing the same. Shall I look into the internals or you're confident? Shall I open it? Cool. It's calling index of open declaration, index of range. See, it's iterating over here. Cool, guys. Right. Now, why it's written if and else condition, that's a secondary thing. We can discuss it if you want. Shall we discuss it? Why it's writing if and else? Do you want to know? Are you curious? See, the point is in the list, you can store two things. Either you can store an integer value or you can also store null. So if you have stored null intentionally and you want to check whether null is present or not, see, that's what it is doing. If your element dot data, see the object which you have passed, if it's null, so this is the operation it is performing. If it's equal to null. So if it's equal to null, it will return that index. Else it will compare the value. Equals method will compare the value. Equals method is being overridden over here. Got it? Right. Let's move back to our original concept. Now let's try to perform the insert operation. If I want to perform the insert operation, let's call it as void, because if insertion happens, if it fails, it's fine. So I want to insert a particular value. What should I do with this value? First of all, get the bucket. So al dot, first of all, I should get the bucket int key equal to hash value, and I'll pass the value over here and I'll get the bucket. Now, should I directly insert into that list, or first of all, I should search whether it is present or not? We should check, and you got the reason why I should check. So there would be a simple comparison key dot, sorry, I should first get the array list, right? I should first get the array list. So this is the code which will help me to get the array list. Now I can check if al dot contains value. If it contains value, sorry, if it does not contain value, then I should perform the insert operation. If it does not contain the value, then I should call al dot add of value. Am I correct? If it does not contain, then only I should add it. Okay, cool. So as of now, just we test search and insert. If you want, you can test delete, or you can implement it by yourself. Now I'll say that, guys, a knowledge of hash map, it's a bit incomplete. I'll do some modification and I'll let you know what things you have to modify. See, as of now, am I creating hash set or hash map? I've created the hash set, not hash map. It's not storing the value. See, name is hash map, but is it storing the value? You're just storing keys, right? There is no concept of value. Correct? Right. So earlier I've implemented the hash map. I'll explain you what was my thought process behind it. Don't take any screenshots and try to get it. So now let's try, and I'll also override toString method. Okay, let's see what does it do. Okay, I just simply want to return list.toString. Cool. I'll do map.insert 10. Then I want to check whether 10 is being inserted or not. So I'll check map.search 10. So ideally it should return 10. Sorry, it should return true. We got true. And let's try to print the map. See, it went in the second bucket based on some calculation. Let's see that. I want to insert the same value again because I want to verify whether it's stopping the duplicates value or not. It's stopping the duplicate values. See, if I won't write that condition, multiple time insertion will happen. When I'm performing the search operation, I have to perform on this list. So unnecessarily, my search and delete will increase the complexity, right? Sorry, search and delete has increased the complexities. So performance will become poor. That's why we are checking it and then storing it. Can you perform the delete by yourself? And shall we see whether it's going to the correct bracket or not? Let's say that I want to insert. Can you tell me any value? Guys, any value? Okay, let's take 21. 21, cool, 21. When you will do the sum of the digits, it will turn out to be 3. Last digit is 1. So 3 plus 1, ideally it should go to the fourth bracket, right? 0th, first, second, third, and fourth. So our theory and practicals are matching. The way we have seen hashing, it's working in the same manner. So code is being simple. You can easily implement it in front of interviewer. Now, there is one of the interesting thing which I want you to learn. Let me zoom in. Are you able to view the whiteboard, everyone? Cool, if it's visible to you. Let's see what it is. There is something called BST. BST says that all the elements towards left would be lesser than the center element, and all the elements on the right would be greater than the center element. For example, okay. Now the point is, if you want to search for 11, let's say, and the center element is first 25, you compare to the 25, where you should search, on the left side or on the right side of 25? Where you should search, on the left side or the right side? Everyone, just think logically. You should search on the left side. You got 10. You should ideally search on left side or the right side, right? You went towards the right. Now, within 3 comparisons, you are able to tell whether particular element is present or not. Even though this bucket contained 4 plus 2, 6 plus 1, 7 elements. There were 7 elements in the bucket, but you were able to tell within 2 to 3 comparisons. Am I correct? So what does Java do? As soon as I figure it out that there are more than 8 elements in a particular bucket, it converts your array list into somewhat this kind of structure. So that even though the number of elements are more, your searching would be optimized. Guys, yes or no? So if you want to implement set, do you know there is a concept called tree set and tree map in Java? Tree set and the tree map. So this is nothing but a structure of your tree set. If you will add values to that particular key, it will become your tree map. You will learn this concept, but later on the stage. I hope I made it clear. So instead of storing, or if you want to implement this instead of list from the starting onwards, so instead of creating array list of integer, you will create array list of tree set of integer, right? And everything will remain the same. Guys, everything will remain the same, but the structure will change. Now think that if there are 100 elements and there are only 10 brackets available, 100 elements, 10 bracket, ideally each will get around 10 to 11 elements, or 10 to 12 elements, or 8 to 12. The point is, even if there are 12 elements, it can be done within 3 to 4 comparisons. This is ideally BBST. but fine, you will understand this later. But it will be done within 3 to 4 comparisons. If it is done in 3 to 4 comparison, 100 elements, 3 to 4 comparisons. Can I say that approximately equal to big O of 1? Right? So this is the entire concept about hashing, what you've learned today. Anyone has any questions with the hashing? Yes, duplicates won't be allowed. Tree set and tree web also do not allow duplicates, if you remember it. You're good? What about others? Was I too fast while explaining the concepts? Clear? Great. What about you, Vishnu? Is it clear to you? You have some questions or clear? Because I don't understand what does. You have some questions? Go ahead.
So, like, how will will we construct binary search tree? And also, I want the code so that I could practice. And
The point is, you do not construct binary search tree when you will use the data structure of like something like tree set or tree map instead of array list, you will get the BST. The point is, if you want to construct binary search tree of your own, that you will learn when you're learning the topic trees. Okay, so again, the point is, if interview is asking you to explain hashing, there are lots of things to explain the hashing, and there is unlimited amount of time. If you will try to implement your own tree set, correct? See, of course, tree set is also in data structure, which is internally binary search tree or BBS tree,
right.
right? The point is, it will become a separate question, and nobody in the industry asked BBST. They used to ask about problem statement with respect to the BST, which you will learn. So it's fine if someone is asking question with respect to the mapping and you're using inbuilt BBST, which is nothing but a tree set and tree map. Okay.
Okay.
Yes.
And one more question, like,
Mhm.
if the keys are repeated, like in array list, we want to store 17 multiple times. It will not happen if we use this tree set. So,
No. So see, the point is, in our code, I've already stopped the duplicate. I know that array list by default allows to store the duplicate.
right.
So, but I have kept the condition. If it is not present, then only store it. If it is not present, then only store it. So anyways, I don't want duplicate. If I'm storing duplicate, it will hamper the performance.
Okay. Yeah.
Guys, am I making sense to everyone? Yes. Okay.
Yeah.
Yes, guys. Anyone has any doubts? No? Share the code. Okay, cool. I'll share the code. I'll share the code. But I'll say first implement it by yourself. If you find it doubts, I'll share the code. Okay. Now, there is one of the interesting problem which you can solve, using hash map. Shall we discuss that? And then standard problem. Shall we? Okay. It will take some time, but it's fine. Let's have the discussion. It's no way relating to the internals of hashing. And of course, in the session, you will learn that. But let's have the discussion. We are having the free time. -1, 10, 7, -1, 5, 6. Okay. Now let's say you have the window, or you can say you have the bag. The capacity of the bag is to store 4 elements. To store how many elements? 4 elements. If you tell me, if I select these 4, how many unique elements are there? 3. If I select these, how many unique elements are there? 4. If I select this, how many unique elements are there? Again, it's 4. If I select from -1 to 8, how many unique elements are there? 4. And if I select from 5 to 5, how many unique elements are there? 3. So you have to print this array. The question can be 2 types. You have to print this array, or the next can be, can you tell me the maximum of this array? Can you tell me the maximum? At one point, how many maximum unique elements you can have in the bag? 4. Am I correct? So the point is, if I'm able to print this list, getting the maximum is an easier part of this problem statement. Yes or no? So do you have any brute force solution? Anyone? I'll give you 3 minutes of time. Just come up with the brute force solution. Just come up with the brute force solution. Optimization, we will discuss it. But as of now, I'm giving you time to think about the brute force solution. Okay. Don't waste the time. Think about it. Did you give it a thought? Everyone? Yes. So what was the brute force solution? Anyone? I can try. Go ahead, Krishna. Go ahead, Kishan. Oops, so just give me a minute. I think instead of unmuting you, I am lowering your hands. Give me a minute. Yes, go ahead.
Yeah, hi.
Yeah, hi,
So,
Kishan.
So we can maintain two lists. One will be list of list and another one will be list.
Hmm.
We will have two iterations, like two for loop.
Hmm.
One will be from like till length of size minus the value which we wanted to see, like k, and size minus k plus 1.
Size
first-
minus k plus 1. Okay, let's have the index 0, 1, 2, 3, 4, 5, 6, 7. So index
Size will be
is
8 minus 4 plus 1, 5, 0
8
to 5,
minus 4 plus 1, which is 5. Okay, you will go from 0 to 5.
3, 4.
Cool.
Less than, it will be less than
So you will go till 4, right?
4,
0
till
to
4. Yep.
Cool.
And inside the first for, I will initialize the another array list, and
Cool.
I'll be having one more for which will start from
Hmm.
I value till I plus k value,
Okay, I to
I to I plus k value.
that means 4 iterations, right? Or
Yep.
k iteration in general.
And inside that, I will check whether the array list is having that value or not. If yes,
Mhm.
we will simply continue. If not, we will add to that array list.
Got it.
And at the end of this for, we will be adding the list to the bigger list, this array list of array list.
Got it, Kishan. There is one flaw in your solution.
Mhm.
The point is, I want to print this.
Yep.
In this array list, once this loop is been done, it will store the unique values.
Yes.
Simply print its size.
Yep.
Again,
And we will
reinitialize
add
the
that
array,
size to this list.
or you can simply print it.
Yep. Yeah, we can do that. Yeah.
Right. If I'm doing that, I'm saving extra space.
Right. This array list of array list would not be required.
Right. And one more thing, like you can optimize in one more way. As soon as why to check every time, store the k elements into the list. That means you have stored -1, 10, 7, and -1. And in that array list, figure it out the unique ones. Do you get the part? Right. And I'll say that why you're even storing in the array list, store in the hash set. If you store in the hash set, you don't even have to worry about the uniqueness or not. Guys, you're getting the solution. What he is doing, from each index, he's trying to add 4 elements into the hash set. See, from 0 onwards, he started, added 4. From 1, he will add 4. From 2, he will add 4. From 3, he'll add 4. This is the last index from which you can add 4 elements. After that, you're not allowed to add 4 elements. Are you getting the point? Others, are you getting the point? Yes, no? No? Cool. I'll explain you the optimized solution as of now. Let's have the flow. Or if it's possible, go through the recordings and listen to this brute force approach once again. Now the point is, whatever you do, your loop is running for n into k time. And if k is equal to n, or if it's k is equal to n by 2, your solution will become big of n square, right? See, you should have an habit. You will say n into k, your interval k, let's say if k is equal to n by 2, your code is going for n square. And if n is 10 to the power 5, you will get TLE. Right? You will get n square, and which will give you TLE. Cool. Okay, now let's try to understand the optimized solution. Everyone, please focus on the optimized solution. Even if you do not understand the brute force, optimal solution is a bit easier than this. Shall we discuss, everyone? You got -1. You got -1. what I'll do, I'll have an hash map. I will have an hash map. Okay, I'll have an hash map. I'll store -1 into the hash map. Is -1 available in the hash map? Guys, is -1 available in the hash map? Initially, hash map is empty. It's not. I'll create an entry. How many times -1 has been present? How many times -1 has been present? One time. I got 10. No entry. I'll make it. Then it's 7, 1. Right. Now, when I'm trying to insert -1 again, is it available in the hash map? Is it available in the hash map? If it's available in the hash map, can I simply increment the count to 2? And the size of the hash map is 3. What's the size of the hash map? How many keys are there? 3 keys. I'll get this. Now, the point is in the next iteration, if you look into the next group, it is from 10 to 5. That means 5 is being added and this -1 is being removed. Am I correct? So I'll add 5 to it, 5, 1, and I'll remove this -1. See, don't remove complete -1 from the map. One of the instance of -1 has been removed. That means if it has the frequency greater than 1, do not delete the key. Just decrement its frequency. Am I correct? See, if you look into the bracket from 10, 7, -1, 5, -1 is present, but it is present one time, not 2 times. That's why I've just reduced the frequency. Guys, do you agree with me in this point? Agreed or not? It's clear to? No. Okay. Why not, Vishnu?
So like my thinking is that even though the -1 is a key, if there are more occurrences, it will go 1, 2, 3. Why are we decrementing the number of occurrences?
The point is, when you were making the insertion, you've incremented it here 2 times. That's why it has become 2.
Yeah.
You're moving forward. Now,
Yes.
this is your new area, right?
Yeah.
And the map also contains the occurrence of -1. I don't want that.
Right.
I should remove it. That's why I've decremented it. Cool.
Okay.
Yeah. Okay. Now, guys, if you look into the third bracket very closely, it is from 7 to 6. That means one more element is removed from the map. Like I have removed -1. I should also remove 10. Yes or no? What's the frequency of 10? It's 1. If its frequency is 1, can I say that I can completely remove 10? The new element is 6. I should insert 6. So 5, 1, 6, 1. Correct? 10 frequency was 1, removed it. Now, if you look into the next bracket is from -1 to -1 to 8. -1 to 8. So what you will do now? What you will do now? What you will do now? You will insert 8 and you will remove 7. Then you will move forward. You will insert this 5, but you will remove this 5. Correct? Can I say that? Can I say that from 0 to k, first of all, make the insertion, print the size, right? After that, After that, keep on inserting the element from k onwards. Let's say k was 4, so you were inserting the elements from index 0 to 3, right? 4 elements. So from 4th index onwards, what should you do? You should insert the element available in the kth position and start removing the elements from 0. So then as soon as it will become k plus 1, remove the first element. As soon as it should become k plus 2, you should remove the second element, and so on. Make sense? Guys, make sense to you? Everyone? So do you want some time to convert this logic into code? Will you give it a shot? Because you already know hash map. As far I have been told, you're working professions and you are aware about all the collections library, right? Give it a shot. If you're stuck somewhere, I'm there to help you. Okay. So I guess 4 minutes are more than enough. We will have a discussion at 9:30. Too much for today. This is the last problem. At least you should study 1 hour, 30 minutes. So I have been instructed you to teach hashing. So 2 days are done. From tomorrow onwards, you will have your regular instructor. Not one more day to solve. I will tell you the solution today itself. Show me the array once. Okay, give me a minute. Yeah, this is the input. Guys, time's up. Shall we discuss? Or anyone has written the code? Shall we discuss? Not fully. You are writing. We can discuss. Guys, shall we discuss? Cool. Still trying to understand. Okay, cool. Let's last. Do you understand the approach, Vishnu? The idea is I'm not uh, talking about any elements. I'm not talking particularly about any elements, but understand that initially we have these elements which are present in these 4 index in the map. Yes or no? Everyone, yes. In the next set, I'm storing these element into the group. The point is only one element is being added and one element is being removed. So for that case, why to empty the list? Just remove the one element, add one element. Again, you can follow the same step. Add one more element, which is nothing but 5. Remove the previous element. Do you get the approach? What I'm doing? A sliding window. One is added, one is removed. Cool. Why hash map? Because there may be a multiple occurrence of it. And I don't want to remove all the occurrence, but I want to remove one of the occurrence. For example, if it is 1, 1, 2, 3, and 4. 1, 1, 2, 3, and 4. If you look into this set, it contains 3 unique elements. So if we'll store into the set, it will be only 1, 2, 3. But if you look into the next group, it is 1, 2, 3, and 4. So 4 is being added and this has been removed. But if I'm removing this, I want to remove one occurrence of 1, not both the occurrence of 1. Do you get the point? Why frequency is being important? Oh, I think I'm in serious trouble. What about you, Bhuvnesh, Gaurav, Aman, Kishan, Racha, Sai? No response. Did I put the bouncer in front of you? Shall I discuss? Sign. Let's write the code. But do you understand the approach? That's more important. Cool. Just give me a minute. Are you able to view the screen, everyone? So this is related to what? This is related to map. Let's keep it on the hashing. New class, sliding window. Okay. So we are sorry guys, I have a bit of the health issues. So let's try to focus. So what we are having an array. And array was having the data int AR equal to new int of 1, 1, 2, 3, 4, and let's take 5. As of now, these many elements. Is that fine? And I'll take k value as 4. K value as 4. I can have more than that, less than that. Let's have the k value as equal to 4. Cool, guys. And what we decided, we will have an hash map. Key would be integer and your value will be integer. So map equal to new hash map. Right, a map has been created. So what we decided, we will store first 4 values into the map. That means first k values. Is it clear? So can I directly put into the map, or I should check whether it is present or not? I should check, right? So can I keep the condition put if absent, put if absent? So how does it will work? How does it will work? Get or default, correct. Right. Map dot put, then I'm updating what I'm doing. I'm putting array of I, then map dot get or default. So guys, it will become too complicated, but I'll try to explain. If you're not able to get it, I'll put the if and else condition. Okay. Let me explain how this code is going to work. So first of all, this is your key. This is your key. This is your key. And then you're calling map dot default on that key. The point is, if there is an entry in the map, if there is entry in the map with respect to this key, you will get the frequency. And to that frequency, you will add 1. So if it is already present, it will become 2. So it will become map dot put off. Let's take any key 1 comma. Let's say 2 occurrence was already there. So 2 plus 1, it will insert 3 into the map. Now it may happen that with respect to the key 4, there is no entry. If there is no entry, so map dot get or default. If there is no entry, it will give you the default value 0. So 0 plus 1, 1. 1 would be inserted, 4 comma 1. Are you clear with this? Or do you want me to write traditional if else? Guys, are you able to understand this? Please respond. You're good. What about others? Clear. Gaurav too. What about Vishnu and Bhuvnesh? Bhuvnesh, is it clear to you how this get or default is working? If there is an entry in the map with respect to the particular key, it will return that frequency or it will return 0. Cool. Get or default. We got it. Now let's try to print this first and see whether we are getting the result in the same way or not. So 1 is being 2 times, 2 is present 1 times, 3 is present 1 time, right? That means it is talking about this set as of now. Am I correct? Now I should insert the remaining elements. So what elements I've inserted? 0, 1, 2, 3. I should insert it for 4, which is nothing but I should insert it from k onwards. Since I equal to k, I less than or equal to n and I plus plus. What is n? N is nothing but size. N is nothing but size of this list, right? Int n equal to ar dot length. Cool, guys. Now I should insert the value which is present in the kth position. That means same piece of code would be executed. Right? Instead of I, it will be, yeah, it's I. Clear? Now the point is, before performing this insert operation, I should remove the value. So what value I should remove? See 0, 1, 2, 3, 4. You are here. That means you have to remove this value. Can I simply say that you have to remove I minus k value, right? I minus k. So will you directly remove or you will check, then you will remove. So you will put the condition, right? If map dot contains, we already know that it is present in the map. So you can simply check map dot get of remove. If its frequency is greater than 1, then what you will do? You will update the frequency. Am I correct? How? Map dot. You will get the current frequency and you will reduce it by 1. Am I correct? Else, you will simply remove the key. Is it clear? Yes or no? So what I am doing, I know that value is already present. So I'll check whether its frequency is greater than 1 or not. So let's try to print the map at every stage. Exception in thread main cannot invoke int value because the return value of hash map get object is null. Okay, it's very strange. Oh, I minus k is index, guys. I minus k is index. I should write array of I minus k. Got it? I minus k was the index, not the value. Oh, see, the maps look like this. And same thing, if you want to compare, let me copy Control C, Control V. See, first is this slot. 1 is present 2 times, 2 is present 1, 3 is present 1 time. Then I need this group. If I need this group, the point is earlier 1 was present 2 times, so I have to reduce its frequency. So this piece of code would have been execute. See, map.remove I minus k. I is at index 4, k is also 4, 4 minus 4, 0. That means remove the value which is present in the 0th index. That means this, its frequency was greater than 1. So frequency was reduced to 1 and the new element is being added the way we were adding it previously, which is nothing but 4 is being added. Now in the next group, this is the slot. Now I minus k, I is at 5, 5 minus k, k is 4, 5 minus 4 is 1. That means remove the element which is present in the first index. That means I want to remove this. Yes or no? This time the frequency of 1 was 1, so it was removed from the map. Guys, as you have seen, insert, search, delete, everything will happen in big O of 1 in the map. So can I say that whatever is written inside this will execute in big O of 1? And overall time complexity is big O of n. So we boil down from n squared to n. And one more thing, how many extra space you are using? At one particular time, we are not storing more than k elements. So extra space is k. And if k is equal to n, n comma n is the complexity. As of now, it's n comma k. But if k is equal to n, it will become n comma n. Let me comment this piece of code. Right? Everyone got it, or was it unbouncer to you? Please respond if it's clear to you. Understood? Clear to you? Okay. Remove the middle bracket on 10. Where? Acha, while commenting. Okay. I got it. You mean this, right? Got it. So do you want to take the screenshot? You can. It's one of the standard problem which will be asked in the industry, not during the interview. So if you want, you can take the screenshots. Now the point is, if he is asking sliding window, you have a clear-cut explanation why you're using map, because you're doing insert, search, delete multiple times, and you want this operation to work in big O fun, and it doesn't matter and which order elements are present inside the map. Now, if someone asks, do you know why things are not stored in the insertion order inside the map? You have the reason, because of the hashing. Once hashing is performed, you don't know at which bracket it will be stored. Am I correct? That's why it does not preserve the insertion order. If you want to preserve the insertion order, there is an option which is called linked hash map. Linked hash map, you can use it. Yes, linked hash map. Let me write it down. So linked hash map. Hash map has said both are available. So I'm not gonna go into the detail about it, but see, once you know the linked list and then you know the map, it will be easier for you to understand. Linked is from linked list. So if you read the description, it says that hash table and the linked list implementation of the map interface. The implement differs from the hash map as it maintains W linked list to all its entities. This linked list defines the iterating order, right, in which keys were inserted into the map. That means it preserves the insertion order. So the point is, it's a combination of your map and the linked list together. So map to perform insert, search, and delete in big O fun, linked list in order to store. That means linked list will help you. First went into the second bracket, second element is went to the fourth bracket, third element is went to the fifth bracket. It will store the where the next element is being stored. I hope you got it. Right? Just a rough overview. If you want, you can go into that. Nobody asked about the linked hash map, but yeah, you will face the question with respect to the linked hash map. Cool, guys. Okay. Thank you, everyone. It's been 2 hours a day. Thank you.